Welcome to my presentation. Pai-parvaaz division A.U.B.H.S presented by awez. Class 9. Roll no U19. Potential and kinetic energy. Energy is the ability to do work. Work is being done whenever some physical force is being used to move an object some distance. Energy means that birds can fly, tigers can roar, wind can blow, sun can shine, cars can go fast, factories can make things, light bulbs can glow, and your computer can work. Without energy, there would be nothing, no light, no movement, no light, nothing.
Now you're going to die.
Energy. All objects contain energy in one form or another. Can take the form of motion, sound, position, electricity, heat, light. It can never be destroyed. It can only be converted from one form to another. This tendency to resist changes in their state of motion is described as inertia. Cardboard and a coin placed on an empty glass. Flick the cardboard with the finger. What do you observe? The coin drops into the tumbler. When we flip the cardboard moves fast, whereas the coin continues in its state of rest and hence drops into the glass. So it is clear that objects continue to remain in their state of inertia or of uniform motion until an external force standing in a bus leans backwards. Rest starts all of a sudden. Fruits fall down when the branches of a tree are shaken. Dust particles on a carpet falls when we beat the carpet with a stick. Examples of inertia of motion. A passenger standing in a moving bus leans forward when the bus stops all of a sudden. A man carelessly stepping out of a moving train onto the ground leans forward. Example of inertia of direction. The water particles sticking to the cycle tire are found to fly off tangentially. Inertia of a body depends upon its mass. That is, massive objects possess more inertia than lighter ones. Galileo's idea of inertia. 1. A ball rolled down an incline would continue up the second incline at equal angle until the force of gravity forced it back down. 2. A ball rolled down the first incline would roll farther up the second incline since the angle is not as steep. 3. A ball rolled down the inline would continue to roll indefinitely on second plane since it would not be affected by gravity. Calculating kinetic energy. If we know the mass of an object and its velocity, we can determine the amount of kinetic energy possessed by using the following formula. Kinetic energy equals 1/2 mass of object, velocity of object, 2. Or K equals 1/2 mv2. Or K equals 0.5 mv2. The SI unit for kinetic energy is the joule, J. A joule is kgm2/s2. A bicycle with a mass of 14 kilograms traveling at a velocity of 3.0 m/s east has how much kinetic energy? K equals 0.5 mv2. Equals 0.5. 14 kilograms, 3.0 m/s, 2. Equals 0.5. 14 kilograms, 200 kilograms automobile is traveling at a velocity of 100 m/s kgm 2/s2. What is the kinetic energy of the automobile? K equals 0.5 mv2 equals 0.5. 1,200 kilograms, 100 m/s, 2. Equals 0.5. 1,200 kilograms, 104 m/s2 equals the measure of how fast an object is traveling in a certain direction. 2/s2 velocity equals 100 divided by time. Distance equals meters. Time equals seconds. Potential energy. The energy of position. The amount of energy contained in an object at rest. Determining potential energy by its position and its weight. Mass x gravity. P equals mass, gravity, height, equals mgh, where m is mass in kg. G is the force of gravity equals 9.8 meters per square second. H is the height. The SI unit that represents potential energy is the joule, J, kgm2/S2. Examine an example of potential energy. A flower pot with a mass of 15 kilograms is sitting on a windowsill 15 meters above the ground. How much potential energy does the flower pot contain? P equals mass, gravity, height, equals 15 kilograms, 9.8 meters per square second, 15 m, equals 2,205 kilograms m2/S2, equals 2,205. Examine an example of potential energy. 2,000 J. If the flower pot is lowered to a windowsill that is 10 m from the ground, does this change the potential energy of the flower pot? P equals mass, gravity, height, equals 15 kilograms, 9.8 meters per square second, 10 m, equals 1,470 kilograms m2/ equals 1,470 J, equals 1.5x103 J. Potential or kinetic energy. Moving cart. Tree branch. Bent car fender. Balloon filled with air. Balloon squirting around room. Person inside a moving cart. What type of energy does the space shuttle have at liftoff? Conversion of potential to kinetic energy. In this picture both kinds of energy are evident. Can you point them out? The water at the top is potential energy. When water falls to a lower level, the potential energy is converted to kinetic energy. Velocity and acceleration. Defining velocity. Kinetic energy was K equals 1/2, mass, velocity, 2. Describes both the rate and direction of the motion. If an object speeds up or slows down in the given direction, we say there is a change in velocity. Velocity and speed. Velocity is a measure of how fast an object is traveling in a certain direction. Example, a bus traveling 15 m/s increases its speed to 20 m/s. The speed changed, so the velocity changed. The bus changes direction and goes east. Since the direction changed, so did the velocity. Car on a circular track equals may have constant speed, but cannot maintain a constant velocity as its direction is always changing. Velocity and speed. Speed is a measure of how fast something is moving, but there is not a directional element to it. Is the distance an object moves per time or how fast something is moving without direction. Speed equals distance divided by time, s equals d divided by t. If speed changes, so does the velocity. Velocity. Velocity equals distance divided by time. The units we use are in/s and d as distance. Acceleration. Acceleration is the change in velocity per unit of time. An example of this is when you travel in your car. Your velocity is not constant throughout the entire trip as you slow down and speed up as necessary. A positive acceleration means that you are speeding up and a negative acceleration means that you are slowing down. Acceleration. Acceleration has the formula. Acceleration equals final velocity, initial velocity. Final time, initial time.
You blocked me on
Or
Facebook. And
time
now
it takes to
you're
change
going
velocity. A equals BF. 6 equals B means change in. TF, TIT. Acceleration has the units of distance unit, slash, time unit. X, m slash s2 or me slash acceleration.
Now you're
Example
going to
acceleration problems. Calculate the acceleration of an object with initial velocity, 0.0 m slash s. Final velocity, 14 m slash s. Time 4.0 s. A equals 14 m slash s, 0.0 m slash s. Acceleration 4.0 s. A car stops from a velocity of 55 m slash s at 15 seconds. What is the car's acceleration? Is the car speeding up or slowing down?
Facebook.
A equals 0, 55 m slash s dash 55 m slash s. 15 s 15s. A equals dash 3.7 m slash s2. Thank y'all. Car is slowing down.